Hello. So today we will we'll do this question search in rotated sorted array. This is very famous question, and time again this has been asked in all the different interviews like Amazon, Google, all interviews. So it makes sense for us to be good at solving this problem. And the way I'm going to solve it, it will be really easy for anyone to understand. And once you understand the basic logic of how to solve this problem, you'll be able to do it in any setting, any interview. So the critical thing here is to understand the basic logic, how to solve the problem. So to understand the basic logic, I will do some of the things and then we'll go about. Okay, so basically, as you can see, this problem is asking to search in a rotated sorted array. And it's asking like there is an array nums and it is sorted in ascending order, but it has been rotated. So see, this is a sorted array, but when we rotate it, we take these 0, 1, 2 and just push these 0, 1, 2 values from the back of it. So it becomes 4, 5, 6, 7, 0, 1, 2. Okay. So this is now rotated one. So yes. So since it is in a sorted array, it makes sense for us to apply binary search on this. And in any binary search problem, what do? We take the two ends, initialize the left or right or low or high to the values of the two ends. So one end would obviously be 0 and another end would be the length -1, that index which is at the last index of the array. And since nums is the array, so we are initializing the end to the last index of the array and one is to the first index of the array, and mid is just, as of now, it is given the value -1, which we will enhance in each and every iteration of the loop, will enhance that. And now in the while loop, we'll do while low is equal to high. We are doing is equal to. Why? Because we don't want to miss that one element. If both of them are, there is only one element, we don't want to miss that. So we know that, first of all, we calculate the mid. Mid is calculated as low plus by 2. Okay. So this is the way we calculate the mid. And then we'll check whether the nums of mid is equal to target. If we are lucky, if you're lucky, then the mid will be at the target. But so we know that we are not lucky. So for that, we have to write this else part. And in the else part, we'll since this question is not a typical binary search question, it has its own variation, and variation here is that it is sorted one. So one thing I would like you to notice that the middle of this array is this part. So this 3 is the middle of this array, but even in this part you'll see that these two parts, they're all sorted. So it is a good thing that these two parts, both of them are sorted. But even if one part is not sorted, like the point where the things are getting mixed, it is the middle point, but it could be that 7 is here only. So even then, one part of the array from the middle to the one end, that one part of the array will be sorted. And we have to exploit this fact that if one part of the array is sorted, then we will be going to that part of the array and doing usual stuff. But for the other part, we may have to do some other logic. So first of all, we need to identify which part is sorted. So how to identify which part is sorted? It's simple, we can just check nums of low is less than equal to nums of mid. So if it is true, if nums of low is less than equal to nums of mid, then this part is sorted, and then we will apply the usual binary search stuff here. Else, if it is not true, then in this case we'll do some other logic. So let's first clear this thing out. So if in the left part, nums of low is less than or equal to target, and target, why we are doing less than equal to? We are doing less than equal to because target is obviously, if the target is equal to nums of mid, then it will fall in this if. But since it is not equal to mid, nums of mid, target is not equal to nums of mid, so it will not come under this, it will come to this. And in this part, we are checking nums of low is less than equal to nums of mid. If it is less than equal to nums of mid, it means that left part of the array is sorted. If the left part is sorted, then if the target is in between nums of low and mid, it can't be equal to mid, but it can be equal to nums of low. So if it is nums of low less than equal to target, and target is equal to target is less than nums of mid. Okay. So we can do one thing, as an enhancement, we can do one thing here. If nums of low is equal to target, return low. Simple. Else if else mid is equal to high is equal to mid minus 1. Correct? If this is not true, then what we'll do? If this is not true, then we will do one thing. We will low is equal to mid plus 1. Done. Now in the else part also there is two cases. If nums of mid is less than the target and target is less than equal to nums of high. So if target is equal to nums of high, return high, else low is equal to mid plus 1, else high is equal to mid minus 1. Okay. Okay. So now let's run this. Okay. Okay. So all example test cases are passing. So we are good. We'll do one more, one more test case. So this one also is passing. We can also check to see that how this result is being executed. So we can put the debugger over here, go into the debugger and just debug it. Yeah, so low is less than equal to high, low is 0 and high is 1, so it is true, so it will come under this thing, and then mid will be low 0 plus high minus low 1 by 2. 1 by 2 is integer division, so it will be 0. So 0 plus 0 is 0. Mid is 0 only. Mid is 0, so 0 is not equal to target. Then since there is only one element, this is true. Target and mid, no. Mid target is not equal, so low is equal to mid plus 1. Low is equal to mid plus 1. Then we go to low, and low is equal to high. Low is equal to high, and then mid is this. Mid is equal to target. So return mid, output 1. So this is happening correct. Let's submit it. So this is 1 millisecond faster than this. So this is working fine. So now we are good with that.